last part of 4.5 and all the movement with sine and cosine functions. So the first day we just worried about the amplitude and basically vertically stretched it. Yesterday we continued to vertically stretch it, and then we changed the period length, so essentially horizontally shifting it, or excuse me, not shifting it, horizontally stretching it and shrinking it. Whereas now the last thing that we're going to do is we are going to horizontally or phase shift it. Okay? Whenever we do this, everything is predicated off of what is inside the parenthesis. Okay? We're going to use B again, just like we did whenever we dealt with our phases. Okay? Whenever we dealt with the phase or we dealt with the period length with our B value, we're going to do the same thing. We're going to use that value B, okay, or the number that's in front of X, and then whatever is with our C value. So it's like whenever we deal with like our H and K, okay, to be perfectly honest with you, I would rather write this as BX minus H because that's what you're accustomed to seeing. It's all the same thing. Okay? It's all the same thing as far as what you're doing. The only thing with a lot of sine and cosine and trig stuff, they're going to use A, B, C, and D. Realistically, it means the same thing as whenever we were dealing with like H and K. Okay? It's not any different. Okay? So if you want to write this, I am completely okay. If you would want to write this as y equals A sine of bx minus h, that means the same thing. Okay? Just like whenever we did it before, whenever h was positive, we move it to the left. Okay? Okay? Whenever it's negative, we move it to, or excuse me, whenever it's a plus, we move it to the left. Whenever it's a negative, we'd move it to the right. So that's not going to change. Okay? It's still the same things. We're still moving things left and right and going from there. The only thing that's different is that whatever that value is on the backside, okay, since our formula starts as a minus C, okay, if it's positive, we've got to change it to a negative. If it's still negative, we just keep it as is. Okay? The only thing that we're going to do different than what we've done up until with quadratics and square roots and absolute value and moving it left and right is that with this, we are going to divide that value by whatever our B value is. Okay? That's how much it's going to shift it from 0. Okay? Whether it be left or right. Okay? So whatever our value is, whatever's on the back end, okay, if it starts as a negative, then it's really a positive. Okay? It's always the opposite. We're just going to take that number, we're going to divide by whatever our B value is or whatever number's in front of X. And that's going to tell us if we go left or right. If it's positive, if it stays positive, we're going to move it right. If it's negative, it's going to go left. It's no different than what it was before. I'll give you a hint. Okay? If this is a minus, it's going to move to the right, just like it did before. If here would be a plus, it's going to move to the left, just like it did before. Okay? It's always opposite, right? Everything in that parenthesis is always opposite. If it's a plus C or a plus H, it's going to move to the left. If it's a minus h or a minus c, whatever letter you want to call it, it's going to move to the right. Our amplitude doesn't change, our period doesn't change. We just have a new starting point, basically. Instead of starting at 0, like we have with sine the entire time, at 0, 0, we're just going to shift it left or right that many units. It's not going to change how we've already done the period. It's not going to change how we've already done the amplitude. Okay? We're just shifting everything over left or right. Same way whenever we deal with cosine, it's going to do the same thing. Okay? Everything fits. We're still dividing whatever our c value is, or our h, whatever you want to call it. Okay? But the biggest thing here is, just remember, if you have y equals a times cosine of bx minus c, it's going to move right. Oop. If it looks like this, and it's a times cosine of bx plus c, it's going to move left. Okay? That doesn't change anything. We're just going to move it left or right accordingly. But if it's a plus, it's going to go left just like it did before, just like with anything else. Okay? The biggest thing that we have to do, or that we can't forget to do, is to divide whatever that value is, whatever's being added or subtracted, by our b value. Okay? By our b value. That's what's going to move it. So instead of starting at 0, 1 for a cosine, we may start at 1/2 and 1. Okay? We may start at 2 and 1. Who knows? Okay? It may actually start at like a negative value and then cross over our y-axis. Okay? All the phase shift does is change the starting point of the period. Okay? You still find your same key points. Okay? You're still going to figure out where the starting point is, where the ending point is, where halfway is, and then where your quarter marks are. Okay? All you really have to do is just either add or subtract whatever your starting point is to your original spot. Okay? Normally, if you figure out, once you figure out how long your period length is, if your period length is still 2 pi and you moved it a quarter, then it's going to be 2 pi plus the fourth, or maybe pi over 4, or whatever it is. Okay? So if we have, it says determine the amplitude, the period, the phase shift of y equals 1/2 cosine of 4x plus pi. So first off, did you like doing, let me ask this first. Alright, so if we do this like we did yesterday, and we basically do this in shifts, okay, or in various different ways. So if the first one is just going to be, the red one would be y equals cosine of x. Where's cosine of x going to start? Like, what's our period length? What are we counting each one by? Where are we going to start? Where are we going to start if it's just regular standard cosine? 1. Okay. So if I'm going to make this, I'll make that pi over 2. I'll make this pi. 3 pi over 2 and 2 pi. Where are we ending? 2 pi. So 2 pi and 1. The negative side is going to be at pi. It's going to cross at, it's going to look something like that there. Agreed. Now, if at the next step we take it and we just worry, so the next day we went and we just changed the amplitude. What's the only thing that realistically changed? Did where it crossed at 0 change? Like at pi over 2 and 3 pi over 2, did anything change? Nope, that didn't change. What did change though? Basically, it was started at a half and it ended in a half. Its low point was at a half. So it looked something like that there. Okay, there in green. Then what we did yesterday was if we just take this blue one, and we had y equals, and we had 1/2 cosine of 4x. So in terms of amplitude, period, and all that, so really the only thing that changed was the amplitude became 1/2. How did the period change? What do we have to do to find the period from yesterday? You remember? What did we do with the 4? 2 pi divided by 4. So we take 2 pi divided by 4. So our period went from being 2 pi in length all the way down to 1/2 pi in length, or pi over 2. So we shrunk this thing down basically 4 units, right? So in doing that, we still are going to start at this 1/2. We're going to go over to 1/2 here, and then we're going to be down at 1/2 there. Does everybody agree with what I've done? We went from the green all the way down to the blue because we cut this thing into fourths, or we shoved it down into a fourth of what it originally was. Agreed? Yes? No? Maybe? What? It is half. That's half pi. So we have our endpoints at 1/2 and 1/2. We have our low point, or the valley, down here at basically pi over 4 and negative 1/2. It's going to cross at basically pi over 8 and 3 pi over 8. So it's going to look something like that. Agreed? Now the last thing. Okay? The last thing is that we're going to put it all together. So we're going to have y equals 1/2 cosine of 4x plus pi. So the phase shift, so we've got the amplitude, we have the period length. Now we're going to have, we basically added the phase shift. What two numbers do I have to worry about? The pi and which one? Bless you. The 4, right? So what is this actually? If it's a plus, which way is it going to move? Left or right? It's going to move left. Okay? So it's going to go left. How, bless you. How much? Pi over 4? Right? Okay? Because, so we move it left pi over 4. So if I basically take it here, because we had pi over 2 and then we had pi over 4, This was pi over 4. Whoop. That was pi over 4 there, so this is going to be a negative pi over 4. All we're going to do is we're going to pick up this blue one, and we're going to slide everything over. So I'm going to take my point, and I'm going to have it here at 1/2. I'm going to go halfway. I'm going to be here, there, and here. So it's going to look something like that there, okay, in purple. So we had the original of the blue where it's just a regular standard cosine function. We took the green one and we vertically shrunk it by 1/2. Took everything as far as my original reference point down from 1 to 1/2, and then from -1 up to a -1/2. We shortened the period, so we took the green one and we shoved it all the way down into that pi over 2. And then the last thing we did, since it was a positive in here, okay, we just took it to the left, okay, pi over 4, and we just shifted everything over, okay. The reference point there at -1/2 was at pi over 4 already, so we just shifted it over pi over 4, which just put it on our x-axis, or y-axis, excuse me. All right, so here we have, so let's do it again. Let's go one step at a time. So we have 4 sine of 2x minus 2 pi over 3. So first thing, if we would just have the standard y equal to sine of x. It would start at 0, it would cross at pi, it would cross back over at 2 pi, it would hit the high point at pi over 2, it hit the low point at 3 pi over 2. It would look something along the lines there. Next thing we would have done would have been to go with y equal to 4 sine of x. So, and I didn't put enough spaces. Now I did. How would that affect? So that's dealing with my amplitude. What is my amplitude now of my new function? What's that 4 going to do to it? Right, everything's going to get multiplied by 4. So my starting point where it crosses and at 2 pi, nothing changes. But at pi over 2 and at 3 pi over 2, somewhere down there, it's going to look something like, kind of missed. Like that there. Then yesterday we had y equals 4 sine of 2x. So if normally it was at 2 pi in length, how did that change our period length? We take 2 pi divided by 2. So instead of it being a length of 2 pi, it's only a length of pi. So now instead, it's still not going to change at 0, 0. It's still going to cross at pi, but it's also going to cross at pi over 2 now. Okay, Okay, we took the green one and we shoved it down, and we basically we put it all the way down, we cut it in half, or we pushed it to where it's half the length. We're still going to be at a positive 4. We're still going to be at a negative 4. It's just going to happen a lot faster. It's going to look something like that there. The last thing we have to do is we have to shift it. So it's 2x minus 2 pi over 3. So which way are we going to shift it? Left, right? Which one? It's going to go right. Okay? So it's going to go right. So as far as our phase shift that we have, it's going to go right. How much is it going to go right? Bless you. What goes on top, what goes on bottom? 2 pi over 3 divided by 2. Okay, divided by 2. You can rewrite this if you want as 2 pi over 3 times 1/2. So it's going to shift pi over 3 to the right. Now, the bad thing about this is, or what makes this one tougher than normal, is that everything with pi, or with sine, excuse me, is pi over 2, pi over 4, so on and so forth. Okay, so we've got to use a little bit of, it's got to be a little bit of a guessing game to a certain point. Because if we go to half, we can't go all the way to a half. It's not nice and neat to where it's going to go all the way to a half. So as far as the graphing side of it, it's really going to be, like if it's normally at 0, it's going to be now at pi over 3. That's not pi over 3. That's pi over 4. So somewhere, not so much in between, but what is that? That's pi over 2. My fault. So pi over 3 is somewhere about there. Everybody good with that? Okay, so as far as where we start and how everything shifts, it's going to move like as far as my beginning, end, you know, instead of being at 0, it's at pi over 3. Instead of it being at pi, it's going to be at about where 4 pi over 3 is. So 4 pi over 3... maybe somewhere in there. Okay. It's still going to go up to positive 4. It's still going to go down to negative 4. And it's kind of a little bit of a guessing game as far as where everything's at. Okay, especially because we don't have like everything, like especially whenever we've got to draw it without the graph and things here. Okay, try to highlight it in yellow. But as far as the shift and everything there, again, this one's not real nice and neat just because normally with sine we move in like halves and quarters and stuff like that. Whereas here we had to go into the thirds. But I think you kind of get the idea. The last thing really deals with the very end. It talks about the vertical shifts. If it's a -1, it's going to go down. If it's a +1, it's going to go up. Or if it's a plus, it's going to go up. If it's a minus, it's going to go down. So instead of maybe starting at 0, you may start at 1 and just go accordingly there. Okay? The vertical shifts are obviously a lot easier just because you're just going to count up or down however many. And normally it's going to be a nice, neat number to deal with.